as we're writing methods, if we declared something to be returned, we have to return it. But even if we don't, we can still actually use return as an option within our program. So typically when I work with a method, I'm going to make a request, like I go to an ATM, I'm going to wait for a response, because that's the default that happens. Anytime I call a method, I sit around and wait until that method completes its work. And then I get the response, which in this case is going to be some cash, plus I get to continue on with my day. Now this is an important example because it's not like I walk up to an ATM, I put my card in and I leave, and then hope to come back later on and get my work. That's called asynchronous interaction. All of the calls to methods in Java are synchronous. There's no way for me to do something asynchronously until I get to threads, and that's a whole different ballgame. And you'll look at that in 351. When you get down the road. But for now, just know every time I call a method, it's like going to an ATM. I'm sitting around and waiting for a response. That response may or may not give me something back, but we're expecting something back when we declare it. So the method return type is what tells us if we're expecting something back. Every method is required to have a return type. It could be void, so I'm not going to return any data to you. I'm just going to give you control back. But it could be a primitive or an array or some reference to like a class, like a string or the other things we've seen. So we've seen all this before, just a reminder of what we've talked about. So returning data to the caller then is done through the return statement. If I say I'm going to return something, I must return something. So in this case, I say calculate total, I'm returning a double. So I need at some point in my method to arrive at a value to be returned. So I create the sum right here. I loop through all the items inside of that, and then I total them up. And most importantly then, I return the sum. So that sum return sum matches up to that statement of returning a double. And the type must be the same. I can't return a string. I can't return a Boolean. I have to return a, in this case, value of double. So if you forget about it, or if you do code like we see here, where I have an if statement, and there's a chance that the code would reach the final curly bracket without returning something, you'll get a compiler error, something such as missing return statement. So in this case, if subtotal was not greater than 0, then what would I do? Return nothing? I can't return nothing. You have to tell the program what to do if something's, if it's not right. So I could say if subtotal is greater than 0, return subtotal, else return 0. That could be an option. But I have to return something through every bit of flow through the logic. Otherwise the compiler is going to yell at you. And when I say return, that means I'm done. So if you look at this code right here, if I say if subtotal is greater than 0, in this case maybe I already am keeping a track of a total locally or something like that, then I return the subtotal. Otherwise, then I'm going to total everything up and return the subtotal there. Now, in general, this is a bad practice, and I slap myself on the hand for putting it out there. In general, in a class, you want to go and ask your contributing things every single time. Only if you know that totaling them up, like let's say to total them up, I have to send 10 people out to the back 40 acres and take some 3 hours to get back to me, and then I can give you an answer. In that case, I probably want to keep a total on hand and return it to you except for if I don't have one, in which case you'll wait 3 hours. But Java applications are really, really quick. And so the better answer is don't keep a variable to keep track of things, especially things that could be changing inside going out later on. It's kind of like saying I'm going to, on the outside of my wallet, write down the amount of money that's inside of my wallet. It's just as easy to open it up and see, oh, I got 320s, I must have $60. That's quicker and more accurate than every time I take money out of my wallet, writing down a new total on outside of the wallet. So that's a little bit, I'm kind of glad I have it here because we can talk about it, but it's also a little bit of a bad practice by me. So anyway, you are allowed to have as many return statements as you want. Anytime you hit a return statement, that's the end of the method. So here, either one of these guys will return, but when it hits it, it's over with. It goes back to the caller, and this method is finished executing. So you can't execute any code after the return statement, but you can have any number of return statements inside of your application. if, let's say, you wanted to print something out and you wrote some code such as this, you would end up with a compiler error such as this unreachable statement. This last statement can't run. So if I wanted to say, oh, by the way, my method's done, I would actually have to be better off saying my method's about to be done because I'm going to return this thing next. There's no way to do a logging statement and return at the same time. Return at the same time. So I have to watch how I code stuff. And it's not a huge deal. The compiler will warn you about it. But if you see this compiler error, at least you know what it means and know why you're getting that error. Now, it's also possible to use the return statement when the type is void. And this is just basically kind of like the break statement. Say, I'm done with this method, I'm out of here. In this case, I do not provide data, though. I just say return. So I'm adding in a product. If I'm at the maximum number of line items I can have, maybe my database only allows a certain amount, maybe my shipping only allows a certain number of items, there could be some rule. If it's full, then I return. So I just don't add the thing in. That's not the best design because I haven't told the user I'm not adding the thing in, but maybe it's okay. I just, especially if it's like a free store or something like that, hey, you can get some free items. Well, once you add it all in, you're full, you move along. So the flip side of all this is as the caller, when I call a method, I don't necessarily have to pay attention to the return type. If it's void, it doesn't return anything. If it's not void, it's returning something, but I'm okay with ignoring that. So I can say items.printReceipt, which maybe goes off and prints something to a printer and doesn't return anything, and that's fine. I can say line item I is equal to items.get for the current product, so I can go get the line item. I can store that. I can do something with it. Or I can say calc total, which returns to me the total. Maybe I ignore it. There's nothing to say I have to do something with the return type. Some languages require that if a method returns something, if a function returns something, I have to deal with that return type. I have to store it somewhere. And there's some logic to that. I mean, why would you call a method with a return type if you weren't storing that? But sometimes in Java, it'll return stuff just in case. It'll return stuff just because, So I've seen it before where you have cascading code where it says add, and you say add something, and then the add returns itself, and so you can say add or something like that. I don't like that type of coding. I find it to be confusing to have 5 or 6 things happening on the same line of code. I'd rather see one thing happen on each line of code, but there's sometimes good reasons why you'd return something, particularly that you don't necessarily need to do anything with. So it is something that's legal within Java. All right, well, that's the foundations of how we build classes. So we specify our class, we add attributes, we add methods, and then within our methods we do things to return stuff. So that's the foundation of what we're looking at, is putting this all together. And so the demonstration that's coming up next will help you kind of put this stuff into context, but there's a lot of good data here you might want to refer back to over time as you're practicing more stuff and being able to build more advanced classes.